Okay. So, should we review the preparation assignment for lesson 16?
Yeah.
Okay. Thanks. I felt like lesson 16 was pretty easy.
Yeah. Lesson 17 wasn't too bad.
No. As long as you know what is supposed to be where, I feel like it's pretty easy. So. And what they're asking. Okay, so part 2, question 6, we were supposed to make pie chart and a bar graph for the information in the file. Which I don't think that's too hard, but I've used Excel before this class, so I didn't have a problem. Did you guys have any issues with it?
Mm-mm.
Okay. So for question 8, it says show at least 5 ways, graphs, and numerical statistics to describe the data above. So we could use those graphs, right, that we put in question 6 and 7. And then I made a frequency chart. And then I wrote out like the little proportions for each of the classes. I didn't have 5 though, I only had 4. Did you guys do anything extra?
Hold on one sec.
I did not fully understand the concept of numerical data assigning numbers to the individuals.
So on the answer key for number 8, it just splits it up the exact same way that the graphs did. It just said, just shows like freshmen, tells you the number there are, and then it gives you the p-value. Sophomore tells you the number, p-value. So it just says freshman, sophomore, junior, senior, and then other.
The proportion?
Yeah, that's all it is for number 8, is that just...
Oh, that's all they put? Okay.
It says your answers could vary. You could have used proportions to describe the data. You could have described the data in words, or you could display them on a frequency table. So if you used proportions, all you had to do was list all 5, to say the number of each, and then put the p-value of each.
Okay. So I didn't write in or describe anything in words, so I guess that was another one. Okay. Well, that's good enough for me. Could we do 9?
Yeah, let's do 9.
Okay, 7% is the true unknown percent of the population that do not have traditional phones and instead rely on cell phones. 7% is P. Suppose a random sample of 750 telephone users is obtained. What's the probability that more than 60% or 60, of phone users, 8% in the survey or use only cell phones?
This
What?
This is such an old thing.
I know.
I'd be like 100%. I'm
Yeah.
100% confident that
Yeah.
at least 60 only have a cell phone.
It's a little funny. What is the mean and standard deviation of the sampling distribution based on 750 telephone users? So the mean is 7%. And then for the standard deviation, we'd use the new formula. Square root of p times 1 minus p divided by n. I got 0.009317.
At 0.0093 for my standard deviation.
Okay, me too.
I had to get a quick correction because I put in 7 for P instead of 0.07 at first. But
Oh, okay. Are you ready for what is the z-score?
I'm playing with it right now.
I'm ready. Sorry, I'm on mute.
Oh, okay.
Forgot.
So the z-score I got with the new formula is 1.073347.
Yeah.
Yep.
Okay. So then for the probability, you just plug the z-score into the applet and shade the top part since we're wondering if it's greater than. And I got 0.1416 for the probability.
Mm-hmm.
Okay. Yeah, I got all the same.
All that? Okay. So should we take the quiz?
Did you plug it into the normal applet?
Yeah, the normal applet.
slightly different z-score from you guys. So it's 0.08 minus 0.07, right? Divided by
Divided by the standard deviation.
0.0093.
Yeah.
You probably got 1.075.
I did, yeah.
Yeah, it's just because we rounded 0.0093 instead of keeping it 0.009316 or whatever.
Okay.
So you got the same thing as us. And then if we want it to be greater, then yeah, area is 0.1416. Beautiful. This is an easy chapter.
Okay. I'll take your word for it.
All
Just after that, brought that thing down.
You guys ready to start this quiz?
Yep.
Yes.
Opening it. Oh, there's only 16. You cry. And the first two are easy, which means there's really only 14. This literally just makes or breaks my day.
The number of questions in the quiz.
Life is good. If it's over 18, I hate the day.
I hate the review ones the most, I think. Well, these are pretty bad. Okay.
Like 30 questions.
Yeah, 30 questions. Just
Well, then I hate the review ones.
break something.
Yeah, I don't like the review ones.
Mine's up.
So is mine.
Almost.
Yep.
Okay, let us know, Alex.
Question 3. I love this question.
I am ready. Scrolling down to find out what question 3 is.
I'm almost positive question 3 is the top one. I'm just very certain.
I like question 3. I wish all of them were just easy.
Yeah, why can't they all be like this? Why can't this whole class be like this? Actually, I kind of like
more
this.
visually appealing when the slices are different sizes.
Then you go for that one. I'm going to choose the third one.
Everybody agrees?
I'll stick with it.
Each slice represents a category. That's the one I'm going for.
Yep.
Although I agree that pie charts are more visually appealing.
They're even more visually
the slices.
appealing, and they're all different colors too.
That's true.
How are
Okay.
bar charts and Pareto charts related?
The last one.
The only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are ordered largest to smallest going.
Yep. That one.
Boom.
You conclude that p hat is normally distributed if np is greater than or equal to 10 and n times 1 minus p is less than or equal to 10, greater than or equal to 10. Yeah, time. Is p the true proportion or the sample proportion? I don't know. I have to look it up.
Well, they all change every lesson, so it's hard to. The sample proportion is p hat.
So it's the true proportion.
Wait a minute, hold on. It says the sample proportion p hat is normally distributed if n is large. Then the true population mean. Yeah, I think p is just the normal.
The true proportion.
The true proportion.
Okay. What is n, the sample size?
I think so.
Yeah, n has to be sample size. Number of candidates in an election. If P is 1/4, what is the smallest n that satisfies the requirement? Well, if P is 1/4, then n has to be 40. And then does it work on this side? 1 minus 40. No, I mean 1 minus 1/4 would be 3/4 times 40 would be greater than 10. Yeah, so 40.
Wait, how did you do this?
Oh,
So 40, if you look at the equation on top, it says we're going to use these for the next 3 questions. It says that n times p has to be greater than or equal to 10. So in order to get the smallest
Okay.
possible, we'd be looking for the equal to 10. So np is 10. So if p is 1/4, 1/4 times 40 is equal to 10.
Got it.
And then it works, it is true on the right equation as well. Will be greater than 10. But anything less than 40 will only be true on the right side and not true on the left one.
yeah, you're right. I was worried about that the other equation that doesn't factor into this, but even then, it would wind up being a sample of 30, so 40.
Yeah, in order to, the lowest number you could get for the equation on the right would be like, I don't know, like 13 or something. Whatever 3/4 times something equals 10.
Okay. Suppose n equals 24 and p equals 0.4. What is the mean of p hat?
Okay, what is the mean of p hat?
I got 0.016 onward.
Isn't it just
How'd you do that?
0, or is it just 0.4?
I did 0.4 divided by 24.
Assuming I got 0.1.
How did you guys do it? The only reason
What?
is it 0.4 is because it says, well, hold on. Yeah, it says on the reading under 3.22 mean and standard deviation, mean of p hat equals p. And then the bottom one is the equation for standard deviation.
So then
That's the
8 would
question
be
I
0.4.
That's what I think.
Yeah, I have it in my notes. Mean of p hat equals p.
And then 9, we just got to do that equation. It says square root of p times 1 minus p of n. So 0.6 times 0.4 divided by 24, square root of 0.01. 1. So standard deviation should be 0.1. I like this chapter a lot. It's a good chapter. You guys ready to move on, or?
Sorry, I'm almost there.
Figuring this out.
So standard deviation 0.1.
The reading under 3.22. Both of the equations are under that one.
Okay, I'm ready for 10. But Alex, are you still working on it?
I got 0.1.
Cool. Brittany's batting average is 0.300. we want to determine the probability she will get more than 35 hits in her next 100 at-bats. M equals 100 and P equals 0.3. What is P hat? 0.3. Right?
That would be the mean. The mean of P hat is equal to
Oh.
P. This one is what is P hat? And P hat is X over N, right?
Mm-hmm. Oh, okay.
So what is, we have N is 100, and then X.
Is it 0.300? Wait, that's her average. She'll get more than 35 hits in her next one. I think it's 35 then. Is it 35 over 100?
It might be. I just gotta figure out
What?
exactly what they mean by X, because I don't trust any variable. Where does it say what X is?
We had to answer that in the prep assignment. Let me pull it back.
Okay, so it says at the beginning,
X is
number, whatever, then X is the proportion of people who favor the Republican. That's,
I still think it's 35 over 100.
it's just weird. Like, it says, what is, we want to determine. Oh, okay. They want to determine the probability, but that's not what 10 is asking for. It's P hat. Okay. And the probability will be in 13. Okay. So it's 35 over 100. So it makes it
0.35.
0.35. I'm good with that. Standard deviation of P.
Yeah, 0.046.
Hang on, guys. I got a crying kid. Be right back.
Okay.
For standard deviation of P hat, did you get 0.0458?
Mm-hmm. I
So-
rounded up to 0.046.
Okay, so 0.046. And then the z-score.
the z-score, I got 1.087.
I got 1.092. I did not use the rounded
The rounded standard deviation.
I didn't do that because on the thing we just did, the individual prep, the answer that was right for the z-score wasn't rounded.
Okay, so maybe I won't round either. Yeah.
0.09.
One 1.091.
What is the probability that you get more than 35 hits? Okay, so I got 0.1.
Okay, sorry guys. I'm gonna be really, really lame. My daughter's throwing up, so I'm gonna be out for a little bit.
Okay,
Sorry.
that's not lame. That stinks. Were you reading 13, Trevor?
What?
Were you reading 13? You were saying something and then he came and was talking too, and I just didn't know if you were asking something or not. Never mind.
No, probability.
Okay.
I got 0.137.
Oh, let me. Okay. Did you shade to the right?
Yeah.
More than 35 hits.
7.4. So I rounded down.
What's the probability that she gets at least 35 hits? Would we shade that differently then? Would
No,
it be?
at least, so 35 or more.
Oh, okay. All right.
They just worded it weird. I looked at that because I was confused for a second.
Yeah, it confused me.
The probability she'll get more than 35 hits.
Yeah. Okay.
And then 13 just says at least, but they're really asking the same thing. So
Makes sense. So 0.138, did you run? 138. Oops. Okay. All right. If the true proportion of people who support a political candidate is P equals 0.52, and if N equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What's the standard deviation of P hat?
dang.
It's a 0.011, right?
Let me see.
Yeah, I got 0.01117. So round to 3, yeah, so 0.011.
Sorry, let me catch up. Yeah, 0.011. What z-score would you use?
I got negative 1.791.
So what did you use for, oh wait, what is p hat?
P hat
So
is
if we're getting less than 50,
5.
it's what? Sorry.
P hat, because they're wanting to see, they want to see if the probability of getting less than 50%.
Mm-hmm.
So that is 0.5 for 50%. Regular P is 0.52. You should get negative 0.02 on top, and then divide that by the standard deviation. But don't use the rounded standard deviation. Do 0.01117 at least.
Okay, I just wanted to make sure that I was getting p hat the right way.
Yeah, and then for the z-score, I got negative 1.7.
Okay, I got that negative 1.790. Okay.
Yeah, but it was negative 1.7905 is what I got. I rounded up to negative 1.791.
I got negative 1.79029.
Did you use the full standard deviation?
Yeah, so for the standard deviation, did you get 0.011171?
Yeah, I just only went to 0.01117. So you're probably right. I just changed mine to 0.
Okay. Okay.
And then probability, I got 0.037.
$0.037, is that what you said?
Yep.
Okay, that's what I got too.
Awesome. All right, I'm submitting it. We got them all right.
Yeah.
I'll leave this open. I'll open a new page so that way when Alex comes back, we can give him the answers.
Cool. Okay. We review lesson 17.
Yeah.
Okay. Mine's up.
Are you doing the prep assignment or the quiz?
The prep assignment, if you want to.
Okay. Only two questions.
I didn't think this was bad either.
What?
I didn't think this was too hard either.
Okay. So part 2, 7, confidence interval, In an October 2008 poll, 684 of the 1,006 randomly selected college students reported that they had been involved in an automobile accident within the last 5 years. That is really sad. A. Find the proportion of those surveyed who have been in an automobile accident in the last 5 years. Proportion, so you just take 684 and divide it by 1,006.
Yeah.
So,
That's 0.6799.
yep. That's what I got. And then check requirements and constructing a confidence interval for this data. Wait,
So you plug it into those two. N times P is greater than or equal to 10. And then N times 1 minus P is greater than or equal to 10. And that's how you check them to make sure that they meet the requirements.
Which it does.
Which, yeah, they both do.
Their sample size is massive.
Uh-huh.
Okay. All right. And then C, determine the margin of error for 95% confidence interval based on these data.
There's another formula. You just plugged everything into the formula. And I got 0.0288.
This Z is the
Z is the 95% confidence. So it's
Yes.
the 1.96.
the 1.9.
1.96. Mm-hmm.
Okay. All right. Do that real quick. Okay. Use P-hat. Okay, that makes sense.
Okay.
And then D, construct and interpret the 95% confidence interval for the proportion of those who have been involved in an automobile accident in the last 5 years. Okay, that's just when we do the lower bound and upper bound numbers again.
Yeah, with P hat and the margin of error. So I got 0.6511 and 0.7087.
Yep. Yeah, that makes sense. All right, and then E, how many college students should you survey if you want a 95% confidence interval with a margin of error of no more than 0.015? Okay, so if we want a margin of error, is that
That's the N equals Z over 2M squared formula.
Yeah.
And then you're supposed to round it up to the next, like the nearest whole number. I got 4269.
You got 4,269.
Mm-hmm.
Yep, and that too.
Sweet. All right.
Yeah.
That's good then. And then 8, now you're interested in testing a claim that over 60% of all students have been in a car accident within the last 5 years. Blah, blah, blah. Level of significance, 0.05. Null and alternative hypothesis. Null. Null is it's equal to 60%.
Yeah.
It's more than 60%. Okay.
Yeah.
And then B, compute the test statistic. So that's just Z.
I got 5.173 after I plugged everything in.
Yep. And you just plug that in the applet.
My p-value is tiny, 0 basically.
You get like a ridiculous area. Lots and lots of zeros. What decision do you make about the null hypothesis?
Reject it.
We reject the null hypothesis. We have sufficient evidence to conclude that the true proportion within the last 5 years is greater than 0.6.
And that'll make sense to me.
Yeah, that makes sense. You guys all ready to do the test?
Yep.
And the quiz?
Yep.
Let's get her done.
It's got 18.
Is FP. With nothing on it. Right?
I don't know how I feel when it's exactly 18. I don't know whether to be happy or sad. The symbol for true population proportion is P.
I agree.
Requirements for constructing a confidence interval are satisfied. Yes. Yep. True.
Yes. Wait, are the requirements for the confidence interval and the hypothesis test the same?
It's the whole NP hat is greater than or equal to 10, and then n times 1 minus p hat is greater than or equal to 10. So
yeah, it's the same for both of those. The hypothesis test and the
100 is equal to 10, so that works fairly. And then 1 minus 0.1 is 0.9 times n is definitely greater than 10.
Right.
So they're both true, I believe.
Ooh. I agree.
Information for the next 5 questions. Sweet. Study of first-degree murder trial was conducted in another state. Random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. That is good proportion.
That's
Fine.
smart.
What?
What did you say, Sheila?
Nothing. So find the point estimate. Is that just 45 divided by 60?
Divided by 60, isn't it? Wait, point estimate of the proportion.
0.7.
0.750?
Yeah. Create a 95% confidence interval for the true proportion. Murder trials is guilty. Input your answers for the margin of error, lower bound, upper bound. Sweet. Wow, it is hitting me right now. I'm really tired. Okay. So for the margin of error, you guys get 0.110.
Sorry, just a second. My margin of error, I got 0.1095. Did I do that right?
Yeah, but
0.
place.
Yeah, 0.9. Yeah, 0.91958. So 0.92.
For what?
Oh, wait. I did get 0. Okay, 0.091958.
I got 0.110.
About 0.109.
Well, I got 0.1095 and then rounded it up to the third.
Okay, so, yeah, so 0.110 then.
Yeah.
Okay. Sheila, do you want me to send you what I put in?
No, I think I figured out what I did wrong.
Oh, did you? Okay.
Oh, thanks so.
And then for 10, it should decrease.
So for the lower bound, I got 0.640. Sorry, you guys.
Yeah, lower bound I got 0.640. Upper I got 0.8.
860. Okay. You increase the sample size, the confidence interval decrease.
11's 20.
20.
12 is 100.
100.
Thirteen's true.
Right.
And then p hat
0.475.
is 38 divided by 80. So 38 divided by 80. 0.475.
Yeah.
Yep.
Test statistic.
For my test statistic, I got negative 2.282.
Same.
Okay. And then for my p-value, I got 0.0112. 0.01.
Yeah, 0.0112.
Okay.
Trying to decide if I
Yeah.
should put the middle, but yeah, I don't think you did. So 0.011. And then reject the null.
And then I think there is sufficient evidence to conclude that the water quality in the area has decreased.
Yep. Well, that is that. Alex, better hurry and get back. Did one of you guys already click submit?
I did. We got them all.
We got them all?
Mm-hmm.
Yay.
Sweet. Yeah, it's gonna be a good test. Oh wait, I need to knock on wood. Probably gonna suck. We're like, oh, it's easy. And then they're gonna take the Z and turn it into a Q. Yeah.
Oh, great.
I'd be like, yeah, you guys think you know it? Take everything you think you know, backwards, and you have to remember both ways.
Yeah.
No longer the P value. We're gonna call it the 7 value. Maybe if we scream really loud, Alex will hear us.
Dealing with a puking kid and a screaming group of people online. I think that I should stop the broadcast, so I'm just going to do that.